Okay, this is part 4 of the June 2023 IGCSE Edexcel Physics paper 1. And we went through question 8 last. Here's question 9. It's about a manometer. A manometer is a device that can be used to measure the pressure difference between gas from a gas tap. So gas from a gas tap. So the pressure here, and the atmosphere. So this bit is open to the atmosphere. Okay? Now, if both sides were open to the atmosphere, like on the diagram here, they'd both be at the same pressure. Now you can see that the side which is attached to the gas tap pushes the liquid, which is in grey, down the tube, the U-tube, and pushes it up. That shows that the pressure in the gas tap is greater than the atmospheric pressure, which is at the opened end. So it says, and it's probably going to explain what I just said, when a gas tap is connected to the manometer, the liquid in the manometer moves due to the additional pressure of the gas. In other words, the side of the gas tap has extra pressure. So this is shown by here, where I've written extra pressure, and it's pushed down the liquid 0.094 meters, two significant figures. Okay, so you know from the pressure equation that the pressure difference is linked to the difference in height of the two surfaces of the liquid, and the equation is pressure difference is equal to density times gravity times the height difference. Okay, so this equation is given to you in the formula sheet, and G, gravity, is also given to you. G is 10, so we've already put the G value in to the equation, so that one is G. So they want you to calculate the pressure difference between the gas from the gas tap and the atmosphere. In other words, how much higher is the gas tap pressure? So we need to know what liquid it is. The density of the liquid is 14,000 kilograms per meter cubed. That's 14 times denser than water. So it's probably mercury. The actual density of mercury is 13,700, I think, kilograms per meter cubed. So this density is, we use the letter rho, yeah? So the pressure difference in symbols will P equals H rho G, if you like, where G is 10, rho is given to us, and H was given to us in the diagram. Yes, the height difference is 0.094 from the diagram. So the height difference 0.094 is from the diagram. 14,000 density is given to us, and 10 is a known constant, and that's what you use for GCSE. At A level, G is given to 3 significant figures, and it would be 9.81. Okay, so if you multiply that together, you get 13,160 to 4 significant figures. That's in pascals, the unit for pressure, but you need to really round it up to 2 significant figures. If you look at all data we've been provided with, all the data provided is to 2 significant figures. So it's 13,000 pascals. Okay, so we've done that, and a lot of students got this one right. The equation is provided, and now to the second part. The graph shows how the velocity of the surface of the liquid, obviously we're talking about the liquid inside the manometer, changes with time from when the gas tap is opened to when the water level stops moving. So initially, obviously before the gas tap is switched on, there will be no pressure due to the gas tap, and there should be no difference in height. and then as soon as the gas pressure is switched on, there is a speed that starts off, so it moves fast initially here, as its initial speed is 47, if you read the graph accurately, 47 centimeters per second, and then it slows down to this 0 after 0.20 seconds. So what they want us to do is they've basically given us a velocity time graph, and the first question is they want you to work out the distance traveled by the surface of the liquid. Well, the distance traveled from a velocity time graph is always the area under the line, yes? So it's the shaded area as I've shown with in red, okay? So it's a triangle, so it's half the base times the height, yeah? When the base is 0.20, I should say, and the height is the maximum speed, the initial speed, which was 47, and then you divide the multiplication by 2, you'll end up with 4.7 centimeters. Okay, so a few students didn't remember that distance is the area under a speed time graph or a velocity time graph, and it's a little bit different because they are mixing up the pressure topic with the motion topic, where normally you'd be asking about velocity time in a motion topic. And of course the gas tap has produced motion in the manometer, so they are trying to apply your knowledge of motion to a new situation to see how you handle it. Okay, so the next bit, it wants you to again use the graph, the velocity time graph, this time to calculate the acceleration of the liquid as it slows down. Well, it's actually a deceleration, yeah, as it slows down from 47 centimeters, the starting point of the graph, to 0, the finishing point of the graph. So it goes down from 47 to 0, so I've done it here. The change in velocity is 0 minus 47, because the final velocity is 0, yeah, and the initial velocity is 47, so it's minus 47, the change in velocity, centimeters per second. So, and the time it took to do that was 0.20 seconds, looking at the x-axis. Okay, so you've got to show that how you worked out, and as long as you've tried to work out the gradient correctly, you'll get 1 mark for realizing you've got to work out the gradient for the acceleration. And the equation is the change in velocity over time taken. I've shown you how you get the change of velocity. 0 minus 47 is the change of velocity, and it took 0.20 seconds to do that. You put the two values in and you'll get minus 235 centimeters per second squared. So giving you the units for acceleration, it's always per second squared, okay? In this case, centimeters. Now, technically, it should be a minus sign, but doesn't look like the examiners are worried about the sign of the acceleration because it is slowing down. So 3 more marks. So there's 2 things that you've got to be aware of from velocity time graphs that they can ask you. The distance being the area underneath, and the acceleration being the gradient. Now, just because they didn't penalize you for getting the negative here, in another question, they could have a mark for students who realize that it should be a minus sign there, okay? Okay, part C says, explain how the gas pressure changes if the temperature of the gas increases, okay? So you know that pressure and temperature are directly related, they're directly proportional, but your ideas, you should use ideas about particles, it says. So they're talking about the kinetic theory of gases, so they want a microscopic understanding rather than a mathematical understanding. So if the temperature increases, we know the pressure will increase, but we want to explain it in terms of particles. So the explain part is why does that happen? And here it starts where I put because particles speed up with temperature, or they have more kinetic energy. They'll accept kinetic energy, but you can't just say energy, you've got to say it's kinetic energy. And if they have more kinetic energy or they're moving faster, they will collide with the container walls more frequently, more often, or more per second. Yes, so as long as you realize it's the frequency of the collisions, you will then get another mark. So one for speeding up or more kinetic energy, one for the rate of collisions increasing, okay? And the collisions, not only do they happen more often, they will also be harder, yeah, in that they'll hit with greater force, yeah? So they hit it with more force. And as you know, force per unit area is on the container walls is what pressure is, okay? So that's what pressure is, and you've now answered the question. So I hope you found that useful. I'll quickly show you the mark scheme, which I think I had on the page before. So there is the mark scheme, and you can look through any part of it you want to, in case you have written your answer in a slightly different way. I'll let you stop the video, pause the video, and you'll be able to use it as you wish. Don't forget, if you're watching these videos, please make sure you like each video you watch. If you found it useful, yeah, that's just help with the YouTube. Otherwise, it doesn't get seen by other students. And share it with anyone who you think will benefit from the way I've answered these questions in their build-up to their GCSE. And don't forget that if you subscribe, you'll be notified when future videos are uploaded. The main use of the channel is with A-level students, but I've done some GCSE videos as well, and one I did last year for students preparing for their GCSEs has already had well over 1,000 views. That was the November 23 paper. So this is the one before it, it's the June 23 paper. Okay, and I'll probably do some more in the build up to the summer exams. Okay, so the next question is about investigation skills. And it tells you what the student's investigating. It says a student investigates how the time taken for a ball to roll down a slope changes, yeah, how it changes with the distance that the ball starts from the bottom of the slope. In other words, they're changing the distance from the bottom of the slope. So obviously they've got a fixed position of the slope, and the independent variable is a distance that they start the ball rolling down from the bottom of the slope. Okay, the student's method is written. He placed the ball on the slope initially 10 centimeters from the bottom of the slope. He releases the ball, starts the stopwatch, yeah, because he wants to measure time. So if he's measuring time after the starting of the ball, the time will be dependent on the distance from the bottom of the slope. Okay. Stop the stopwatch when the ball arrives at the bottom of the slope. So he's measured the time difference. Record the time taken for the ball to roll down the slope, and repeat for different distances. So he's then going to change it from 10 centimeters, maybe to 20, then 30, and so on. Okay, and if you're doing a good experiment for GCSE, you want at least 5 different distances, okay, to get a good graphical analysis of the situation. So complete the table by placing a tick, yes, to show which variables are the independent, which is the independent, which is the dependent, and any controlled variables that you think need to be ticked. Okay, the surface of the slope, that doesn't change, so it means it's a controlled variable. The angular slope, they didn't talk about that, so that's another controlled variable. The distance that you start the ball, the distance the ball traveled while you're timing it, is the independent variable, and the time taken depends on the distance that you've chosen. So time taken is what you measure, or the dependent variable. Okay? They then done it at, as I predicted, 5 different distances. So here are the 5 different distances that they've chosen to use, and they've taken the time for each one to 2 decimal places, being consistent. So that's something that you should watch, that all the data should be to the same number of decimal places in this case. And if you were criticizing this set of results, he should really measure the distance to the nearest millimeter. That means he should have 10.0, 20.0, and so on. Okay? Now it's going to ask about this equation in the next question. Okay? So d divided by t squared, they want to know if it's a constant. Well, the way I would suggest, you could always do it in the table. Yeah? So you could put that in the table and see if the numbers come out to be constant. But what they initially want you to do is to plot the student's data on the grid provided on the next page. Yeah? And they want you to draw a best fit curve. So they're telling you it's a curve, and that's going to give you 2 marks if you do it properly. Okay? Make sure you show your points clearly and they're not covered by the line. So the best thing to do when you're plotting, the points must be accurate. So if all your points are drawn or put in the correct positions, which you can see I put them as pluses, not as dots. Don't just leave them as dots, because if you do them as dots and then you're covering them with the line, the dot will become invisible. And if it becomes invisible, then the examiner can't see that you've plotted accurately. So I always say to my students, use pluses or X's, but pluses are better because they go up and down the lines. They go up and down, and they go along the lines, and that's really the advanced way of doing it. Okay? And then once you've drawn the smooth curve, it's got to go through all the points that you plotted as smoothly as you can. And this bit is extrapolating, where you should be able to work out that if the distance was 0, obviously the time would be 0. So you can guess or predict that it should go through the origin. Yeah? If there was no distance to travel, of course it would take 0 time. So most students were able to work out that the dots should go to the origin, but they're just looking that you can draw a curve of best fit. So if your curve finishes over here, I think that's okay. Yeah, they'll still give you the marks. So there's your 2 marks. Then it's the bit where I told you about the analysis. The student concludes that the results obey this relationship. Yeah? Distance divided by time squared is a constant. Well, you saw on my graph, I'd calculated them all, and you can go back and have a look. And if you've done 1 correct calculation, you should get 1 mark. Yeah? And you should show your calculation. And then if you've done it for 2 masses, you should get 2 marks. Yeah? Obviously, if you do it for all of them, you should get more marks. And then you should compare the constants and comment on the constants that you've calculated. Yeah? Because that allows you to have a consistent conclusion. Yeah? Based on your comparisons. So the final bit was that you've written a conclusion which you should say, yes, the student's data does suggest that the distance divided by time squared is a constant, and that will be the 4th mark. Hope that makes sense to you. So that's another question done, 10 marker. Yeah. And here's the mark scheme on it. If you want to stop it, you can. Yeah. Question 11, then we're going to try and do this in one go, because my students will use this tomorrow to make their own corrections when they get their papers back, and it will just give them an opportunity to continue with whatever they do in class when they go home and finish it off. And I don't want to spend tomorrow doing this. Okay, so question 11 looks like it's about electricity, which we'll come to. and it is indeed a light emitting diode in this circuit, and a resistor in series with a cell and an ammeter. So the ammeter is measuring the current, and the cell is providing 1.5 volts, which is what normally cells produce. So the 1.5 volts is shared between the LED, which is getting 0.63 volts, and this resistor, which we have to work out. Well, if this 1.5 volts, the 1.5 volts will be shared between this and this, so you should be able to work out that the rest of the 1.5 volts will be going to the 95 ohm resistor. So it tells you the voltage across the LED, and for resistances or components with resistance in series, they share the voltage. You know that from the circuit rules, and as they haven't spelt it out for you, but that's what they expect you to do. Okay, so they want you to calculate the current in the circuit. Well, we don't know the resistance of the diode, but we do know the resistance of the 95 ohm resistor, and if you can work out the voltage of the resistor, you can then use the Ohm's law, I equals V of the resistor divided by the resistance of the resistor, to work out the current in the circuit. And you'll know that the current in the circuit is the same everywhere in a series circuit. So they're trying to see if you know the circuit rules. Okay, so they want you to calculate the current in the circuit, and they want you to give your answer in milliamps. Okay, so first of all, you've got to work out that the voltage left for the fixed resistor is 0.87 volts. If you take away 0.63, which the light emitting diode is using, there'll be 0.87 of the 1.5 volts left for the resistor, and therefore we know the voltage and we know the resistance. We can then use the current as a subject of the equation. Yes, we can see the arrow where it comes from, and you work out that the current is 0.00915 amps to 3 significant figures. They then want you to give your answer in milliamps here. So that means moving the decimal place 3 places, and it will be 9.15 if you use 3 significant figures, but really you should use 2 significant figures, so it will be 9.2 milliamps, because the data provided in the question is all to 2 significant figures. Hope that makes sense. So that was voltage shared in series. Now you've got a parallel circuit. Diagram 2, it says shows a second LED and the second extra resistor connected in parallel with the cell. So this time the same cell is providing current to 2 strands or 2 parallel paths, and it says in the next section that the resistor and the LED are the same components as in diagram 1. The 2 resistors are identical and the 2 LEDs are identical. So this is giving you the information you need, that the 2 paths are identical to each other. That's like having one loop this way, yeah, which will produce its own current, and this, the second one, will produce a second current out of the voltage. Now, because they're the 2 paths in parallel, they both have direct access to the cell. Okay, so basically all that's going to happen is whatever the first path will get, the second path will get as well. So basically the battery will be drained more quickly. All right, so explain how the ammeter reading at the top of the circuit, how will the ammeter reading here be affected by having a second parallel path added, an identical second path added? Well, so the extra parallel path, I said, will draw an identical current to the first path, okay? Because it's connected to the same voltage, yeah? So if you realize that both paths have exactly the same voltage, which is the voltage of the supply, which was 1.5 volts, then the total current will increase, yeah? Or you could say the ammeter reading will increase, because that's how they have put the term in the question. How will the ammeter reading change? It will increase. If you say it will double, then you'll get 2 marks. It will, because they're identical. So whatever it was reading in the first part is now going to produce exactly the same current, because each path has exactly the same total resistance, okay? And each path has exactly the same voltage. So the resistance of 2 paths is lower than the total resistance of the circuit decreases, yeah? The total resistance of the circuit decreases, or you could say the resistance of the total resistance in the circuit halves, which is why, yeah, this decrease leads to the doubling of the current. So there's different ways of ordering this, but that's basically understanding how the circuit rules work. Okay? The next question is from Unit 6, which is on magnetism and electromagnetism. In this case, we're talking about electromagnetic induction and coils, which are used in a metal detector. So it's called a device called a metal detector can be used to find metal buried underground. Okay, remember, metal buried underground. A metal is a conductor, and this is about electromagnetism. So you've got to think about it. So if you've got a coil in the diagram, it mentions that you've got a transmitter coil, so that's transmitting something. Yeah, what do you think will be transmitting? And then on the inner circle, there's a receiver coil. Okay, now isn't that a bit like a transformer? Yes. So the 2 coils, one is transmitting and one is receiving it. So isn't that something similar to a transformer for those of you who have studied transformers? Now, if you're doing double science, you will not have studied transformers, so it will be a bit more tricky. But it's the last question on the exam, so they want to see how well you can use the theory to come up with the solution. Okay, so what you have studied is what is called electromagnetic induction, that a changing magnetic field will induce a voltage in a conductor. Okay, that's the underlying principle. The metal detector has 2 circuits, as I've shown you. Yeah, the metal detector has 2 circuits, each containing a coil of copper wire. So you've got the transmitter coil and you've got the receiver coil. Okay? Diagram 1 shows the circuit for the transmitter coil. Okay? So here's the transmitter coil. It shows that there's some electronics involved, which is controlling the transmitter coil. Let's see what they say about it. So when you have a complicated question like this, you've got to take in all the information and just think about what have you been taught in the electromagnetism course. Okay, so suggest why there is a magnetic field. So they're walking you through this question by saying, why is there a magnetic field? Well, we haven't talked about magnetic field. But remember, in electromagnetism, there's coils, and if you put a current in a coil, yeah, it will produce a magnetic field. So Why is there a magnetic field around the transmitter coil? Well, we didn't know there was, but they're hinting that it's going to be about magnetic fields. Yeah? Why is there a magnetic field? Because it must have a current in it. Anything with a current in it, a coil with a current in it, will produce a magnetic field. Okay? It then says the cell supplies direct current. So that initially the cell in that diagram produces a direct current, or DC. The electronics, however, in the circuit, in diagram 1, changes the direct current into alternating current. Doesn't tell you how it does it. So they're changing DC into AC. Okay? Now, if you have an alternating current, so instead of it being a direct current, this coil here has AC going through it. That means the alternating current is constantly changing, and that means not only is the current constantly changing, but the magnetic field will change in phase with the current. Okay? So you have an alternating current and an alternating magnetic field. Okay? So what? Let's go on. Describe the difference between direct current and alternating current. Well, direct current travels in one direction only. Yes? Whereas alternating current is continuously changing direction. Yeah? So it's from mains electricity, from topic 2, and you need to say continuously changing direction. You don't say it travels in both directions. You have to say constantly changing direction to get the 2 marks. Okay? So that's explaining to you that we have a constantly changing magnetic field, yes, as I've drawn here, and due to the constantly changing current. Okay, so you're going to have an alternating magnetic field, or a constantly changing magnetic field. So it's telling you that this alternating current is supplied to the transmitter coil. So if this metal detector is constantly producing a magnetic field that's changing, the conductor under the ground will feel, or the charges inside the metal ring, the free charges, the free electrons if you like, will move in accordance with the constantly changing field. Yes? So the electron will be pushed one way, then the other, pushed one way, then the other, pushed one way, then the other. So this is the effect of what we call electromagnetic induction. It induces this inside the ring, it induces a alternating current in the ring. Okay? Because basically the changing magnetic field is cutting through the ring. And as long as you've got a changing magnetic field, you will induce a voltage. You are meant to say inducing a voltage rather than a current. Okay? So explain why there is an alternating current in the gold ring. Well, I've explained it with my graphs. So let's see how we put it into words. Okay, so let's explain why there is an alternating current in the gold ring. Well, the AC in the coil creates an alternating or changing magnetic field, which I've drawn here. So, and the changing field is felt by the ring, and what we say is it cuts through the gold ring. It cuts through the gold ring. Yeah? And if it's constantly changing, and the gold ring is a conductor, yeah, then this causes electromagnetic induction. In other words, it induces a voltage in the gold ring. Yeah? And that induced voltage will then produce an alternating current in the gold ring, which I showed you here. An alternating magnetic field will produce an alternating effect in the conductor as well. Okay? Hope that makes sense. This is quite a complicated question, and even one of my year 13 students said, oh, that's quite difficult. Yes, and then they've just done magnetism in year 13. And finally, the last part of the exam, 110 marks. I think this paper is actually 109 marks because I had to change the question on astrophysics as we haven't covered it yet with an alternative question. Okay, it says diagram 3 now shows the circuit for the receiver coil. So that's the second coil. Okay, now the receiver coil, you can see, is connected to a loudspeaker. Yeah, that's so you can hear when something happens and it detects a metal underground. You have to think about how it will work. It says, as a result of the alternating current in the gold ring. Now, so the gold ring, we know it has its own current in it, and alternating current is induced in it from the voltage. Yeah, there is an alternating current also in the receiving coil. So when the gold ring has created its own alternating current, yeah, it means it also has its own alternating magnetic field. So an alternating current will produce an alternating magnetic field as well. So say this is the top one is the current, yeah, and the second diagram is the magnetic field. That magnetic field that you're producing in the gold ring will be detected by the coil in the receiver, just the same way as the gold ring could detect the changing magnetic field. Now that changing magnetic field will induce, again in the same way, voltage in the receiver coil. So explain how an alternating current causes a sound to be emitted from a loudspeaker. So we now know that because the receiver coil also then picks up the alternating magnetic field, and it will then produce its own alternating current, and that's feeding into the loudspeaker. The loudspeaker has a coil in it. Yeah, it produces a magnetic force or a magnetic interaction. Yeah, and on the speaker cone. Now inside a loudspeaker, you need to go and look at it, a diagram for it. It has its own little coil. So the current is feeding the coil in the loudspeaker, and because it's alternating, the force in the coil keeps changing direction because it's being fed by an alternating current. And by Fleming's left-hand rule, if the current's going one way, the force will be one way. If the current's going the other way, the force will be in the opposite direction. So the current keeps changing direction because it's AC. And because of that, the loudspeaker cone vibrates. And if the loudspeaker cone vibrates, vibration emits sound. Yes? So it causes a sound due to the vibrations. Now I would say I agree this is one of the more difficult questions you'll get in GCSE, but that's why they've put it at the end of the exam to see which students have really understood their GCSE course. And this is a 12-mark question, which brings us to the end of this walkthrough of the exam. I hope you found it instructional or helpful, and if you did, don't forget to like the video, share it, use it to improve your own answers, and if you're one of my students, make sure you do your corrections in purple pen, and we'll spend a bit of time in class on it as well, but you won't be able to finish it all, so you'll need to do the rest in your own time. Okay, so there's the final question in the mark scheme. And thanks for watching. Make sure you subscribe because more videos, especially paper 2, will be on its way probably by next weekend. Okay, bye for now.